In this video, I'm going to talk about what I think is the ideal architecture or the ideal way to build your apps if you're going to use Jetpack Compose in December of 2020. And this December of 2020 thing is very important because, as you'll learn as I go through this video, I suspect that things are going to change. I think things are definitely going to change in 2021. By the end of 2021, I think you're going to see a pretty drastic change to the landscape of Android with respect to how we architect our applications and how we build out the navigation. First, I want to paint you a picture. I want you to get an idea in your mind of what an ideal application would look like in terms of architecture and navigation. What would make you happy as a developer and make your life easy? And I think most of you already kind of think this, even if you don't already you're not already like aware that you're thinking this. It really has to do with the Android lifecycle, fragments and activities, and the difficulties that we run into all the time because of the lifecycle. If you think about it, most of the hardships, most of the difficulties that we run into are because of the lifecycle. If you do a rotation, all the data is lost. It's not persisted by default. The screen does some weird thing, and then boom, your app is in some weird state. It's because the fragment gets destroyed, it gets recreated. The activity gets destroyed, it gets recreated. Most of the problems, probably like 80% of the problems that you run into when you're building applications are due to that life cycle. It just does weird things, and you have to account for those weird things in the event of a rotation, in the event of process death. It just is not pleasant to deal with. So with Jetpack Compose, I think a lot of people are hoping that it's going to kind of make fragments and make activities go away. And it's for good reason. Like I said, most of the problems that we encounter are what happens when you rotate the screen, what happens when the process dies, how does the fragment or the activity cause issues to your view state? How does it change the view state because of these weird life cycle events that really don't help us? They're kind of like just they were part of the framework that we had to deal with. Imagine a world where you could open up a view and there's a list of data there. You're scrolling through the list, doop-a-doop-a-doo. You go, you're really scrolling really, really far. Then you decide to click on one, and then you decide, I'm going to rotate the screen at that point. What happens? Is the data still there? How does that view now look? So maybe now you go back to that list that you were originally at. Is that list position maintained? Is that list position still at the one that when you click that item and you went to that detail screen? These are things that you have to manually deal with. They don't just get handled out of the box. Also, if you're scrolling the list and you decide to rotate, is that list position maintained? Is the data still there, or does it get lost? All by default, all of these things get lost on rotation. Imagine a world where everything was just the same. You rotated the screen, boom, I'm at the same list position. Everything is exactly the same. The data is still there. I didn't need to go and get the data again. Maybe I click on one, I go to the detail screen, I go back, I'm still in the same position. Everything is exactly the same state. That's a fairy tale. That's a fairy tale that I think all Android developers wish was true. So right now, as of December 2020, I think that Jetpack Compose is pretty close to being able to accomplish this sort of a build with their composables. So being able to essentially get rid of activities and fragments almost completely and only use composables. Flutter actually does this already, which is surprising enough. The way that they handle navigation, the way that they handle bringing up their views and maintaining state is pretty ideal. If you're looking at something, you rotate the screen, you come back, everything's pretty much exactly the same. Even if you have a dialog up in view, you rotate the screen, that dialog's still going to be there. List positions are maintained. All of these things just kind of work magically, which is really, in my opinion, how they should work. But it's not like anybody's fault. It's not like the Android team's fault or anything like that. It's really, I think we're just dealing with old technologies that we have been built on top of over and over again over the years, and really the underlying problems haven't been solved. Like, why do we even have a life cycle? Why do fragments and activities get destroyed when you rotate and then get recreated? This is like a fundamental problem that we have right now. Okay, so now that you understand what kind of probably the biggest problem with Android development is, which is pretty much all wrapped around the life cycle, how will composables solve this problem? And can they actually solve this problem already as of December 2020? Well, they're very close, like I said. And here I'm going to now outline kind of the major issues or the major pain points with doing that currently right now, again, December 2020, and what I think needs to happen in order for it to move forward and be able to pretty much design an application with all composables, which would be very similar to how Flutter does it with widgets. It's essentially the same thing. You build a screen and you have some kind of navigation routing system, even navigation components, which I'll talk about. And yeah, so let's talk about these problems. What are the things that Compose can do right now so that you could actually build your application with strictly composables? And what are the issues with those current methods? First, let's start with a diagram so you can just kind of visualize what I'm talking about. So suppose we have a single activity in our application. Now this could be a single activity, but we can also do a single fragment. So I'm just going to call this main activity. Also, you could imagine that there is, a single fragment. It doesn't really matter. Maybe there's one fragment in the whole app, and that's in the activity. But I don't know, for the sake of simplicity, let's just say it's a single activity because it really doesn't matter. Single activity, single fragment, whatever. So what would this look like in an ideal scenario if you were using Jetpack Compose? It would mean that you would have a bunch of screens. So maybe you have like launcher screen. Let me just draw a square around that. Maybe you have a login, screen. And these are all composables, keep in mind. And, register screen. I'm going to write fast, so my writing's going to be really bad. And all of these are just kind of being composed, and there's a navigation system, like a custom navigation system that is built into the activity. So let's just call it the navigation graph, and that exists inside the activity, and that's what manages the backstack. That's what manages, how to get from the launcher screen to the login screen, how to get from the login screen to the register screen, or whatever, how to get to any of the other screens in the application. So currently this is technically possible. You could do this with Compose, but what are the issues with this? What kind of issues would you run into if you built your application using all composables and like a single activity or a single fragment? I think naturally, probably most of you will have the question, how do you handle the navigation? Of course, you could build a custom navigation system, which wouldn't be that big of a deal. You would just have to manage the backstack, have some kind of a global object that sat at the application level and managed, what happens, managing the backstack essentially. So that's one way, but there's actually an easier way that's already built. Navigation Components has a dependency that you can add to your Jetpack Compose projects, and it helps you to build out your navigation system. So very, very similar to how Flutter does it. You can essentially design these routes, which are just strings, and visit those routes. If any of you do web development, again, very similar to also web development, where you have URLs that visit certain pages. It's kind of the same thing. You have sort of URLs almost, quote unquote, that live within your application, and then calling the navigation kind of global object and saying navigate to this URL, and then it would bring up that composable. So this is pretty awesome. I'll actually show you the dependency and show you the page in the documentation where that exists. So if you go to developer.android.com, Jetpack Compose and navigation, this page shows navigating with Compose, and it shows this extra kind of dependency that you can add. I'll actually increase the font size so you guys can see a little better. This dependency right here, Android X navigation Compose. So if you take a look at this page, there's kind of a navigation controller, just like with navigation component. You can design this sort of this global sort of nav host object and have routes that define composables. So this would be a route, the profile route, which will inflate the composable profile. The friend list one, which would inflate the friend list, and so on. So this is one way that Jetpack Compose helps you to design this navigation system with composables. So technically, you could say that the navigation is a solved problem at this point. You could design your navigation using only composables. Okay, now, so navigation's fine. So that's kind of like point one, navigation. That seems like a solved problem with composables. What about state? So what about maintaining the state in each composable? Because when you rotate the screen, that even if you have one activity, it's still going to get destroyed and recreated, which is going to cause the screen to be recomposed. Also, if you have anything, like if you have been using Jetpack Compose at all, you know that changing a stateful composable causes it to be recomposed when that value changes. So what happens when you rotate the screen? Is that data lost? How can you maintain state in these composables? So this problem is this one is kind of a tricky one, because what you can't use view models in composables. Like you can't tie or scope a view model to a particular composable. That would solve the state problem. If you rotate, the view model would persist and the data would persist in it and therefore show the data still. That would solve the problem. But currently there's no way for composables to get tied to a particular view model. Now, this isn't the end of the world. This is technically still a solvable problem. There is a saved instance state function that you can use inside of composables, and you can just declare it at the top of the composable at the top level. If that composable is recomposed or destroyed, recreated, it looks into that saved instance state function, looks for the thing that you saved, and it will still be there. Essentially, it will persist. So technically, this is a solved problem outside of big lists of data. Of course, you can't save big lists of data to the instance state. There's I believe 2 megabit limit on the instance state, which is 250 kilobytes, which isn't very big. It's not a lot of space. So you can't save like large lists of data. You can't save big data essentially to a saved instance state. Not even I wouldn't even call that medium-sized data. You can't save a lot to a saved instance state. So this is sort of a solved problem, but not really. And I think when you really see the rest of what I have to say about Compose and all of this topic about this video, the issue really is it does almost come down to the view model thing. If you had a view model that you could scope to a composable, I think this would be a real thing that we could do, but I'm going to talk more about that later. So point number 2 is persisting state in the composables. Technically, you could do it with saved instance state, but if you have a complicated UI with a lot of stuff going on in it, saving everything to the instance state will probably make you reach that 2 megabit limit pretty quickly. And so really this is a solved problem, but not really a solved problem. Also, what about your business logic? Where does your business logic go? Currently the current recommended way to build your apps, which is the way that I build apps, is you have your view model, your repository or your use cases get injected into your view model, and all of the sort of business logic is either in your use cases or in your view model or a combination of both. So what happens when the view model goes away? How do you handle use cases? How do you handle business logic? Where does that go in a composable? Now for the third point. What about dependency injection? And I guess also additionally, we'll call it a fourth point, which is testing. What about dependency injection and testing? Now, I know that technically you can do testing without dependency injection. Just if you don't use dependency injection and you're writing tests, it becomes very tedious, I guess. And exponentially, as your app grows, it's going to become more and more difficult to write, consistent tests because you don't have those dependencies that are already predefined. You're not passing them through the constructors. It's going to make building out tests more difficult, especially again, as the app gets bigger and bigger. It just is going to be more difficult to scale. It's going to be more headaches. So what about dependency injection? And I think this is just where the theory of being able to build an app with only composables pretty much just falls apart. You can't use dependency injection on composables. You can't declare composables as dependencies. You basically, any dependency injection framework or library, Dagger, Hilt, Coin, Codeine, none of them support, injecting dependencies into composables or providing composables as dependencies. And if you can't do that, it makes testing a lot more difficult. Technically, you could do, manual dependency injection. You could build some class that holds all of your pre-built dependencies and instantiated inside of a composable. But what would happen is composables are pre-built or rebuilt or recomposed all the time whenever things change. Whenever data changes in that composable, it gets recomposed. That would mean that the object that you instantiate, aka your dependency container or whatever it is that contains all your dependencies, it's going to get pre-built over and over and over and over again. I don't think that would be very good for performance. So currently right now, I don't think there's any sort of way to do this. Dependency injection with composables is not a solved problem. And I guess let's talk about one additional point, which is, we'll call it point number 5, is what about using the camera? What about using Bluetooth? What about using any other sort of Android internal hardware component? I actually don't know the answer to this. I'm actually just asking you guys, how would that look in composables? Because these things are typically tied to the start activity, get results sort of system inside of activities and fragments, sort of, almost coupled with the life cycle. It's sort of kind of built into that sort of mechanism and the way to do things. I don't know how that would work with composables. Maybe you guys have some ideas, but I don't think that it would work particularly well, at least at least yet. So overall, to summarize all of the issues around, building an app with complete composables, having, one activity or one fragment, and then all composables. First issue is navigation, which is arguably a solved problem, especially with the that navigation component dependency for Jetpack Compose. Looks pretty good. You can build a top-level navigation file, define routes, navigate to those composables. Seems good. So that would be the first problem. Second problem would be state, which is, I think, really the nail in the coffin. You don't have any way to persist state in composables. You don't have no way to tie a view model to a composable, to scope a view model to a composable so that the state in that composable will persist. You can use savedInstanceState, but as I talked about, there are issues with this. You can't save, there's a 2 megabit limit on the things that you can save to the instance state. So you're gonna, that's gonna fill up pretty quickly. You can't save lists, pretty much at all. That limit is pretty small. Third issue is dependency injection, and then fourth issue is testing. So dependency injection, again, no way to do dependency injection into composables, no way to provide composables as dependencies, which would make testing, especially as your app scales, more and more tedious, I guess we would say. So given all of this information, all of these issues, and how we really wish we could build our applications, what is the way in December 2020, if you want to use Jetpack Compose, how would you build an application? And I think there actually is a really great way to do it, a way that is better than the current way, which would be, building a bunch of fragments, a bunch of activities using old XML. Yeah, I'm calling it old XML now because we have Jetpack Compose. What is the way that I would build Compose apps today, right now? Let's actually go look at another diagram. All right, so number one is I would have a single activity. I'm going to call it main activity and draw it at the top here. Number two is I would have a fragment for each screen in your application, meaning if you have like a launcher screen, I would have a launcher fragment, and that would be its own screen. And then inside of, well, here, I'll actually draw a couple of other fragments. So then inside of each fragment, and of course use navigation component, I would use navigation component, define a navigation graph inside of the activity, and then that would manage all of my navigation. Inside of each of these fragments, we would have a view model. So each screen would have its own fragment and its own view model. That way, the data will persist. We don't have to worry about rotations, saving stuff, or persisting across process death. We can just save the view state to the saved instance state, and we can restore that. And then each fragment will have composables. So just like I've showed you earlier in this course, we would have composables. So maybe this one has, I don't know, C1 and C2. Maybe this one has, we'll just call it C3. Maybe this one just has, C4. You could have any number of composables. It doesn't matter. The point here is we have one activity at the very top with a navigation graph. We have a bunch of fragments, a fragment for each screen to be exact. Each fragment will have its own view model that will persist its state. And then we have the composables, which get their state from that view model. So we don't have to worry about rotations. We don't have to worry about process death because we can just save to the instance state and restore. This, in my opinion, is the way to build applications using Jetpack Compose in December of 2020. Now, there's a couple of reasons why I think this is the best way. Number one is all the reasons that I just said. We can persist state easily. The state can be saved in the view model. Everything essentially that was in place before can still exist there. It's very easy to transition. All you would need to do is get rid of your XML and use composables instead. Your dependency injection stuff would all be the same. Your activity stuff would all be the same. Your navigation graph would be the same. Your fragments are essentially the same because they have the view model, and all of the business logic is from the view model and then backwards in the architecture. So none of that changes. The only thing that changes is the fact that you're not going to use XML. Instead, you're using composables. So of course, there's code changes related to that. But if you were working with a big code base, you could do it piece by piece. You could do it fragment by fragment. And all you would need to do is replace the XML. This is the best way, I think, not only for all of the reasons that I talked about before, persisting state, the view model, dependency injection, testing, but also because it's easy to transition to. It's a lot of the current Android mechanisms or tools would not change. You can still use all of those things. So I want to give a special shout out to a YouTube subscriber, somebody who left a comment on one of my videos. I was thinking about doing a video like this one, talking about like the ideal way that I think to build an app with Jetpack Compose in 2020 or right now. But I wasn't quite convinced that people would want to watch it. So shout out to this guy. I'm going to butcher his name. I'm sure I'm going to attempt to say it. I'll put it up on the screen here so you guys can see how it's spelled. I don't even know. Najim. I'm not sure how to pronounce the J. If it's a H or a J. Sheik. That's probably how to say his last name. So that's pretty good. So let's say Nahim Sheik. Hopefully I said that right. Shout out to him because he left a comment that said, do you recommend using the Compose variant of Jetpack Compose? So what he means by the Compose variant is that Jetpack Compose navigation component dependency that I showed you at the beginning of the video. And that sort of, there's a lot of things that I needed to say in order to answer that question. So I decided to make kind of a full video on that. So thanks for that question. I'm sure a lot of people had the same question. You know, essentially it's that fairy tale thing that we all want to be true. Can we build an app with all composables? Do we still have to deal with the life cycle? The answer to that right now in December 2020 is yes, you still have to deal with the life cycle. So having a fragment for each screen, a view model for each fragment, and then having composables inside of those fragments, I think is the best way right now if you want to stick with all of the current Android things that we have available, whether it's dependency injection with Hilt, using view models, building out use cases for testing, all of these things you can still use if you build your app this way. So now I'll just finish up by saying that in the future, probably my guess would be by the end of 2021, this is going to be a solved problem. My guess, or my hope, I guess, is that they somehow scope view models to composables to persist state. If that happens, it's pretty much a done deal because almost all dependencies are injected from kind of the into the business layer, and then from the business layer into the view model, and then that's how everything works. Your UI just looks at the view model and all the dependencies are into the view model. So really, if they can get the view model to be scoped to composables, it's a solved problem. You pretty much would not have to use fragments or activities outside of some unique scenarios. Well, you need to have one activity, but outside of unique scenarios, you could pretty much build your app with composables, which I think would be awesome because then you don't have to deal with the life cycle. Well, you sort of do, but it's still a nicer way to do it. I think, in my opinion, rather than use fragments, which is similar to how Flutter does it. It's almost the same way that Flutter does it. You know, you define the routes define the destinations, and so on and so on. You've heard it before. Probably lots of you tried Flutter, so you know. So anyway, thanks for watching. I hope this was helpful. I know we didn't write any code in this video, but there was a lot to be said. A lot of beautiful diagrams were drawn by me. And do not forget to leave engagement. Go down to the comment section, write, Mitch, here's your engagement. Come and eat your delicious engagement. Write something weird, something funny. I've been enjoying reading your guys' comments about engagement, so don't forget to do that. Don't forget to leave a like. Thanks for watching, and I'll see you in the next video.